All right, today we're going to be putting together a couple of other concepts in something called stoichiometry. Now, balanced equations are written in terms of moles, but in a lab we can't actually measure moles. We can only measure masses or volumes. So we have to be able to move between the masses and volumes we get in a lab and the balanced equations that we know reactions happen in. So say we need to produce 18 grams of hydrogen gas in order to proceed with the next step in an experiment. How many grams of zinc will we need to initially react to get that 18 grams? This is what actually happens in a lab, and these calculations are actually a pretty important tool that we use in chemistry. So we can relate the different reactants and or products using dimensional analysis. We started to hint at this yesterday when we were doing mole-to-mole conversions. We're going to find that that mole-to-mole conversion, which is going to be our second conversion factor, and is going to come from those coefficients in the equations. So we're going to start with a volume, mass, or number of particles of one material, mostly mass and volume. Then we're going to convert it to moles of that compound. We're going to use the coefficients to switch between the two reactants or products, a reactant and a product, and then we'll be able to find from moles of it the volume or mass of it. So what is this going to look like? So just like before in all of our dimensional analysis, we're going to start with what we're given. We want those 18 grams of hydrogen gas. So the first step is just to go from grams of hydrogen to moles of hydrogen gas. Okay, so there we're just using simply the GFM of H2. Now here, just again, we have H2 is diatomic, so we do have to plug in 2 grams for it. So now I'm in moles of hydrogen. So this is the next step where we're going to take them from our coefficients in the equation and convert between moles of hydrogen and moles of zinc. So these are the coefficients from the equation. It's allowing me, again, to move from what I started with, moles of hydrogen, to what I want to get to, moles of zinc. And then finally, I'm going to use this to go from moles to grams of zinc using the GFM of zinc. And we can see here that when we do that and we multiply across the top, divide by the bottom, we get 588.6 grams of zinc. That's the mass that we would have to start with in regards to zinc in order to make those 18 grams of hydrogen. All right, so let's just do a couple other examples so you can see again kind of the flow of these calculations. So here we have a combustion of methane. It's asking how many grams of water are formed with 8 grams of methane react. So we're starting with 8 grams of methane. We want to know how much water. So just like before, we're going to take grams of methane, convert it into moles of methane. So 16 grams is the GFM of methane. Remember, I'm starting with grams, so I have to put grams in the bottom, and that's going to 1 mole of methane. Then I'm going to convert between what moles I'm starting with, moles of methane, to what I want to get to, moles of water. Both of those came from the coefficients up in the equation. And then finally, since I'm finally in moles of water, I can now go to grams of water using the GFM of water. Okay, you can see in this case that we get to cross out all of our units. We're left with our target unit, which is grams of water. When I multiply across the top, divide by the bottom, I get 8 grams of water, or 18 grams of water. All right, here we have another one. We're going to have ammonia reacting with oxygen to make NO and H2O. So how many liters of oxygen are needed to produce 216 grams of water? So our goal is to find out how much, again, oxygen do I need in order to get and produce these 216 grams of water. So just like before, I'm going to go from grams to moles of water using the GFM. Remember, our second conversion factor, this spot right here, is going to come from our coefficients up here. We can see that we have 6 moles of water for every 5 moles of oxygen. So the 6 moles of water, since that's what I have up in the numerator here, is going to go down in the denominator over here. And then our 5 moles of oxygen up in the numerator. So now if I were to stop here, I'd be in moles of oxygen, but I want to keep going to liters. Now, we're not going to grams of oxygen, so we're not going to use the GFM, but we're going to use our other relationship that we know about, that 22.4 liters, and then I plug grams in there. So we're just going to go with grams since it's already there, and not find liters. We'll talk about how to actually find liters in class tomorrow. So 1 mole of oxygen is going to be equal to 32 grams of oxygen. So in terms of grams, we're going to find 320 grams of oxygen. And again, we'll do some examples tomorrow with liters as well. All right, so you guys are all set. These will take a little bit of practice, but you guys will get the hang of them, and we'll be moving on before you know it.